Hi everyone, welcome back to my channel. This video is going to cover two commands in one. Systemctl for managing services or daemons, Journalctl for viewing system logs. This topic is going to span at least 2 videos, maybe 3. Let's jump right in. So where do these two commands fit in the grand scheme of things? First, we have to look at how the OS boots up. You power on the machine, you get post, then BIOS or UEFI, the grub menu, the kernel is selected, and the OS starts to come online. When the OS starts to boot, you have the very first process with the process ID 1. This is systemd. Older versions of Red Hat called this init. So systemd starts, then launches all of its descendant processes. SSHD for serving SSH connections, auditd for audit logs, systemd journal for the system journal, hint hint, and so on, just to name a few. These services are defined through system units, and there are a total of 11 types. But these 3 that you see here are actually service units. Now to view and manage system units, we use the command systemctl. Now through systemd journal, several processes and applications send journal log entries, like kernel messages, audit records, system log, the logger command, and so on. These messages come out as binary data and are placed into a file. Now the way we can query the journal log is via the command journalctl. So systemctl to manage services, and journalctl to query the systemd journal log. Before we jump into bash, the VM console doesn't give us a lot of real estate for output. So I'm going to enable the ability to putty. We'll go into the settings of our VM, go to network, notice I'm using NAT, click on advanced, then port forwarding. We come up here to add a new rule. We'll call this rule SSH, set the host port to 2222, and the guest port as 22. And what this is going to allow is anytime we connect to the host port of 2222, host being my laptop running VirtualBox, we're going to be forwarded to the guest port of 22, guest being the VM itself, and which is where the SSH daemon is listening. So we'll open putty and type localhost, then port 2222, and I'll save this connection. And if this is your first time connecting, you'll accept, type your credentials, and you're in. Now, if we type systemctl by itself, unelevated by the way, we can view a lot about the system's current state. There's 5 columns in this output: unit, load, active, sub, and description. The unit column tells us the unit name and the unit type via the extension. The load column tells us whether the unit file was actually loaded into memory. It has 7 possible values. The active column is a high-level description of each unit state and also has 7 possible values. These 7 values apply to any unit type. The subcolumn is a low-level description of the active state and is specific to the unit type. For example, device units have only 3 possible substates, whereas service units have 18 possible substates. And don't worry, none of this information has to be memorized. Later, I'll show you how to quickly reference this information. And description is description. Another thing to be aware of is all of this output is being displayed into what's called a pager. One giveaway is this line indicator at the bottom left. Also, if we hit H, we can see we are using the less program as our pager. We won't go into much detail here over the less command, but I want to show you this feature right here. Searching. And Q takes us back. If we are not sure of the unit name we are looking for, we can search for it with the / and typing our regular expression. And we have a couple of matches. If we want to ignore case in our regular expressions, type -I. And we'll jump back to the top. Now we can also adjust this output from the get-go if it's too noisy. We can tell Systemctl to show only specific unit types with the type option. So we can display only the service units if we want. Or tell Systemctl to show us service and device units only. And so on. You can also filter on the load, active, and sub columns, again with a comma separated list. So here we can display only the units that are inactive, or units that are inactive and are of type service. As you can imagine, you can get very creative with this, but the main takeaway is there are plenty of ways to search Systemctl's output via searching with the /, filtering with Systemctl itself, or even a third way, globbing using the list units subcommand. Although this example is case sensitive. So many different ways to search Systemctl's output. Now, if you want to view all installed units, use the list unit files subcommand. In here, we are introduced to two more columns, state and preset. These are called enablement states. Preset is the default enablement state of when the unit is installed. And state is the current enablement state set by you administratively or the OS. And you can use the full name of the system unit, or you can glob. So now, we are aware of 7 different columns. Now here's how to dig into the details of a particular unit. Type Systemctl status and the full name of the unit. If you leave off the extension, Systemctl will assume .service. So if it's not a service unit, make sure to specify the full name or use globbing if you're not sure. We have 2 matches, but now we can find the full name and use it. And the one we're going to demonstrate for the rest of this video is the SSH daemon. And also notice we are given the 10 most recent log entries by default. Now before we jump into administrating services, I want to give an advanced tip. When you run Systemctl status, we can actually view all 7 of the columns we were introduced to earlier. And here is the unit name, load, active, sub, description, state, and preset. To manage a system unit is actually very straightforward. With elevated credentials, we can stop a service and confirm that it's stopped with status. Start it up again. We can also tell the unit to reload its configuration file and many other subcommands detailed in the man page. Now, one concept that can be confusing for some is the idea of disabling a unit versus masking a unit. Disabling a unit means that it will not start at boot time, but if you run Systemctl start, the unit will run. However, when you mask a unit, you cannot even run systemctl start without getting an error. We'll demonstrate this now. We'll disable the SSH daemon, and systemctl status does confirm this. But notice the service is still running. So now we'll stop it. If you also want to stop the service when you disable it, add the now option from the get-go. Remember, disabling only prevents the unit from starting at boot time. So we'll reboot the server and test this. And our putty session terminated as expected. Now the server is back up, and we'll try putty again. And we can't connect. So let's log into the server and see what we can see. Service is not running, so we'll start it and make sure it's running. Try putty again. Now we'll mask the service . Reboot . Log in . And try to start the service again. And the OS gives great information with a systemctl status and when we try to start it. So we'll unmask the unit so we can start it. Then we'll enable the service so it starts at boot time.